Welcome to lesson cuatro cinco punto. Yes, I speak Spanish. That is also known as 4.5. This is the side-splitter theorem. The side-splitter theorem happens to be my favorite theorem in all of mathematics. That's a lie. I don't know why I said that. I just lied to you. I'm sorry. So what is the side-splitter theorem? This is what it is. A parallel line, all right, and we know what parallel lines are. They probably look something like these two lines, all right, through a triangle, splits the size of the triangle into two proportional pieces. Yeah? You see what's going on here? It's called the side-splitter theorem because a parallel line splits the sides of a triangle. Huh? So what does this sentence even mean? Let's make this a little clearer, okay? Well, let's say this. If I know that DE is parallel to CB, if I know that this line right here, then I know it cuts the sides of this triangle into proportional pieces. Meaning, pay attention close here, the ratio of AD to AE, that's my top portion of both these, AD to AE, all right, is proportional to the ratio of DC to EB. All right, and that's the whole theorem that we're going to be discussing today. All right, these proportions, the proportion of those two sides to each other is going to be the same as the proportion of these two sides to each other. That's it, baby. That's it. So let's get into it. Let's see if we can even do this. All right. Well, in triangle PQT, we know that RS is parallel to PT. Oh man, I see that parallel thing going on. It's probably the side-splitter theorem that's going to help us out. What is the length of ST, which is this length right here? All right. We want to find this guy right here, ST. So let's put a little X there. Well, this is what we know. I know that the ratio of this portion to this portion of RQ to SQ is going to be proportional to the proportion of RP to ST. RP to ST. This is to this, this is to this. All right, let's plug in some numbers here. RQ is 4, SQ is 5, RP is 8, ST is X. Let's do some cross multiplication up in here. We get 4x is equal to 40. We're going to divide both these sides by 4, and guess what we get in? Tell them. We got x equals 10. Ooh, yeah. So, if anyone asks me what's ST, I would tell them the answer is 10. Yo, done. All right, let's give this another shot. All right. In the diagram below of triangle ABC, we know that BA, which is right here, is parallel to ED. All right. We also know that AE is 14 inches. This guy right here is 14. Okay. We know that AC, this whole thing, is 21 inches. And we know that BD is 6. All right, let's put that in there. And BD is 6 inches. We want to find the nearest tenth of an inch the length of CD. All right, so CD is right here. That is going to be our X. Now, we do have some good information here, right? But the problem is, the way this theorem works is that it's the top part to this part is going to be proportional to this part to this part. But I don't know what CE is. I don't know what CE is, right? I know what the whole thing is. I know AC is 21, and I know AE is 14, but I don't know what CE is. Well, how am I going to get CE so I can use my theorem, right? I've got to use my theorem. I have to know what CE is. Well, guess what? If I subtract 21, which is the whole thing, from 14, which is this part of it, then I'll be left with the remaining piece of it, right? So let's give that a shot. I'm going to do over here 21 minus 14, all right, and that gives me 7, like that. So this is 7, and that makes sense, right? Because 7 plus 14 equals the whole thing, which is 21. So if you ever know the whole side and one of the pieces, you just subtract them, and that gives you the missing piece. Now I can set up some proportions, right? So I know that CE, the proportion of CE to CD, CE to CD is going to be proportional to AE to BD. AE to BD. All right. Let's plug in some numbers here. We know CE is 7. We know CD is X. We know AE is 14. And we know BD is 6. Let's do some cross multiplication. We get 42 is equal to 14x. Divide both of these by 14, and I know it says find it to the nearest decimal, but you know what? This works out perfectly because when we divide that, boom, and we get x equals 3. That is a beautiful, beautiful job. Ba, 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 ba. So the length of CD is 3. Let's give it another shot. Let's just do one more. I think one more is in order, right? In the triangle below, we know that JK is parallel to YZ. It's an important point. We can't use the side-splitter theorem without the parallel. They have to be parallel to use the side-splitter. Side-splitter must be parallel. Must be parallel. That's why they got to state that. If XY is 18, so that's my whole jam right here, okay? XJ, why did I write XY instead of 18? If XJ is 4, so that's right here, and that's just 4, all right? And XK, which is this guy right here, is 10. I want to find out what XZ is, which is the whole thing. Now I know what you're thinking. This looks confusing. Well, actually, it's not. You don't believe me? I'll show you how to do it. Well, the first thing is, remember, we got to find out what each of these portions are. So I need to know what this portion is, and I need this portion, and I need to know this portion, and I need to know this portion. All right? Well, if I know the whole thing is 18 and this part of it is 4, just like we did in the last one, we could just do 18 minus 4, which gives us 14. And that tells us what this other part is right here. So this is 14. Okay, now let me make a little room. There's just too much stuff written over here. All right, let's get this all out of here. All right, a little too much information. So this is 4, and this is 14. And we know that because 14 plus 4 is 18, and I just subtracted the 2 to get my answer there. Congratulations, us. No, it's just too much. Chill. Chill. All right. Now, if you remember, xk here is 10. But the thing is, I want to find out what this whole thing is. Well, how am I supposed to do that? We don't know the formula. We only know this guy. But here's what we can do. If we can find out what kz is, then if I add kz plus xk together, then I can find out what the whole thing is. So let's set up a proportion here, okay? I know that xj, this guy, xj to xk, all right, xj to xk, is going to be proportional to jy to kz. jy to kz. If you plug in these numbers, you get 4 over 10 is equal to 14 over x. Let's do some cross multiplication up in here. We get 4x is equal to 140. Divide both sides by 4. We get x is equal to, well, let's see, that goes in 3 times 35. Wow, nice. Now we're not done, right? Because this question is asking us for xz, not what kz is. So, if I know that kz is 35, all right, let's put this right here, and I know this part is 10, why don't we just add these guys together, right? And find out that 10, which is this part right here, plus 35, which is the other part, and that gives us 45 for our whole thing, xz. So our answer is xz, which is the question, is equal to 45. Make sure you're answering your questions here, guys. All right, that's it for this lesson. I know, you're like, that's it? No more math? No, that's it. So you can go cook your mom some dinner and look her in the eye and says, thanks for birthing me. Just say it, because she wants to hear it. Oh, and don't eat cockroaches. They're poisonous.